All right, guys, welcome back to Statistics with Mr. Robeson. Today, we're going to look at how we can do the inverse or the opposite of the stuff we were doing last time with the normal distributions, the normal CDFs. We're going to go backwards this time, and we're going to look at a lot of examples. Don't worry, calculator's there to help us. All right, so before we move on, we got to make sure we can go forward. So here's a review problem. The weights of male black bears at Yellowstone National Park are normally distributed with a mean of 262 pounds and a standard deviation of 43 pounds. What is the probability of an adult male black bear weighing more than 300 pounds? All right, so if you want to stop it and work it out, feel free, be my guest. All right, so I'm going to write down what we've got here. So we've got a normal distribution with a mean of 262 and a standard deviation of 43. So remember, this is one way we can write it, where this is the mean, this is the standard deviation, and we're just getting those numbers from up here and up here. And we want to know about being more than 300 pounds. So we can draw the curve if we want. We don't necessarily have to, but it's good practice to draw it with 262 right here. There's our mean. And somewhere up here is 300. It's about one standard deviation up, so maybe right around here is 300. And we want to know about being more than that, so that's this section up here that we would shade in. All right, so now in order to find this, we would go to normal CDF on our calculator, which is under the distribution menu number 2. And then it asks for a lower bound, an upper bound, a mean, and a standard deviation. All right, so our lower bound is going to be the 300 where it starts. Our upper bound, we just want to go up to something really, really big. All right, because this is going to really go up forever, actually. So we're just going to pick a big number. If you want to, you can write like positive infinity or something, but I just put 100,000. A 100,000 pound bear could attack our city. Who knows? It could happen. All right, our mean is 262. Our standard deviation is 43. And we can just throw that into our calculator. Where's our calculator? There's our calculator. So second distribution, number 2. We've got a lower bound of 300. There's going to be a lot of typing in here today. One with a bunch of zeros. Doesn't matter if it's the same number I typed there or wrote there or not. 262, that one's got to be right. 43, that one's got to be right. And we're just going to press enter a couple times until we get a number. Oh, there's an answer, 0.1884. So here's our guy here, option D, 1884. All right, so before we move on to the next thing, I do want to take a look at this question. What percentile is the bear that weighs 300 pounds? So that means up here we've got I'll just run around, 0.19. So that means over here we've got 1 minus 0.19, which would be 0.81. So in other words, we have 81% of the data right here. So this would be the 81st percentile. All right, so just quick reviews of percentile. So if we have that percent of data below the data value, that is a percentile. All right, so 300 is the 81st percentile. So now we're going to work on going backwards. All right, so when given a probability or percentile, you want to calculate the value. So this is using the inverse norm. So this is going backwards. So before we were given values and we wanted to calculate probabilities or percentiles or percents. Now we're given those probabilities or the percentiles, and we want to go forward to find the data value. All right, it's on the same distribution menu. It's just the next one down. It even has INV, which stands for inverse norm. So we're using inverse norm. I usually just call it inverse norm. All right, it's going to ask us for an area. So we enter that area in. That area is always the area to the left, unless you have a fancy calculator and you get to choose left, right, or center. We're always going to do them left because some of the calculators don't have that option. Some of them do. All right. Then it'll ask for the mean and the standard deviation. Then we'll press enter a couple times so it gives us a number. If we are using the TI-83, you're separating them by commas. The first number you're going to put in is the area left, then the mean, then the standard deviation. And this is always going to be some sort of decimal. Like for the last one, it would have been like 0.81, would give us back the 300. All right, so let's look at some examples. So given for the SAT EBRU, I guess is how we pronounce that nowadays. That's the evidence-based reading and writing. When I was a kid, we just called it the verbal section. It's a normal distribution with a mean of 533 and a standard deviation of 110. That's what this means. So it's normal, mean, 533, standard deviation 110. How high must you score to be in the top 10% of students taking the test? All right, so I always like to draw the curves with these guys because it helps me picture what's going on. Even if my curve doesn't look great, that's okay. So here's 533, and we want to be in the top 10%. So that means we want this to be 10%. So that means the area below it will be 90% or 0.90. Remember, these two always have to add up to 1, and we are trying to find that x value right there. So that x value will equal the inverse norm of, let's see, and the area that we're going to do is the area to the left. So area left is 0.90, and then our mean is 533, and our standard deviation is 110, and we're going to throw that in our calculator. So there's our trusty calculator. Second distribution, inverse norm. Our area is 0.90. I always like putting the 0 anyway. You don't have to. 533 for our mean. 110 for our standard deviation. And paste, enter. There it is. So we would have to score, it looks like we can just round that up to the nearest whole number. That x here is going to be 600 and, was it 74? I probably should have paid attention to that. 74 is what that would round up to. So 674 or higher would get you in the top 10%. So if you scored over 674 on your SAT verbal section, good job for you. All right, what score spread would be the middle 50%? All right, so this one's a little trickier. We want to be in the middle 50%. Basically, it's finding your IQR, or your first quartile and your third quartile. Boy, that's a terrible looking graph, but you know what? It'll do. So the middle 50% will be, in between these two data values, will be 0.50. If it's the middle 50, then that means this over here is 0.25, and this over here would also be 0.25. So we want to find this x value and this x value. So I'll call them x1 and x2. All right, so we're just going to do them one at a time. So first we're going to find x1. So to find x1, we're going to do the inverse norm. We've got our area left is the 0.25. Our mean is still the 533. Our standard deviation is still the 110. So we pull up our calculator. And we're just going to type that in. Second vars. We could just press second enter and just write over it, but we're going to practice going to the right spot. So 0.25, 533, 110, they're both still there. And there's one answer. Here's your shortcut, second, enter. And we just want to change the other one to 0.75. 75% because it's the 50% in the middle and the 25% at the bottom that it's greater than. So that's 75% that's below it. So here we go, 0.75. So we got 4, it looks like that'll round to 459 and 607. So we get that x1, 459, x2 is 607. So the middle 50% is from 459 to 607. All right, what is the IQR of these SAT verbal scores? So now that we've got both of these, so this is Q1, so this was the first quartile right here. So Q1 is 459, should probably put a 1 there. Q3 is 607, so remember IQR is Q3 minus Q1, so it's going to be 607 minus 459, and whatever that works out to. I'm getting lazy today, so we'll just throw it in here. 607 minus 459, and 148 is what we get for our answer. So our IQR is 148. All right. All right, so now we just got some examples. So exam grades in a large statistics class are normally distributed. We need that to do these sort of problems. It's got to say that. With a mean of 79 and a standard deviation of 12, find the lowest score that is greater than 80% of all grades. All right, so again, I always like to draw a picture first because that helps me figure out where things are and what's going on here. So here's my normal curve. I know it's normal because it says that it's normally distributed. All right, our mean was 79. Our standard deviation was 12, so we got that. So 79 should be right here in the middle. Find the lowest score that is greater than 80%. So we want to be greater than 80%. So we'll be somewhere up here, and we'll have 80% below it. And we want the lowest score, because all these scores up here would be greater than 80%. Some of these would be greater than more than 80%. So that's the one we want right there. So there would be, in case you're curious, 20% would be above it, 80% would be below it. So if we're trying to find an x value and we've got the probability already, or in this case the percentile, this would be the 80th percentile. So that's the other way they could ask this. They could say find the 80th percentile. We're just going to do inverse norm. And I do suggest writing this out on the AP exam. Calculator language, it's okay. Some people say they don't like it. I'm a big fan of it. 80, mean 79, standard deviation 12. And the reason why I like it, because it says it's normal. It's giving you the area. It gives you the mean and it gives you the standard deviation. That's what the AP graders are looking for when they grade these problems. The picture will also give you that, but I don't see the standard deviation labeled here, so we need to write this also. All right, so you can write this, and that gets you covered. That covers everything. All right, so now we're going to type that in. So second vars inverse norm. We've got 0.80. We're at the 80th percentile. We've got a mean now of 79. We don't have to press clear. We can just start typing over it, and it'll erase it. And it's 12 for the standard deviation. And that gives us 89.09, so roughly 89. So this x value here is roughly 89. All right, and there it is, answer choice E. Voila. All right, here's another one, a little trickier now. All right, so this was on an AP exam a couple years ago, if I remember. So the height distribution of a 7-year-old girl's is approximately normally distributed, with a mean of 47 inches and a standard deviation of 2.7. I do like underlining while I'm reading the questions because I know those sort of things are going to be used later. Alicia, 7 years old. Okay, so she fits the demographic. And her height is 0.96 standard deviations above the mean. Okay, we can use normal to find that sort of stuff. Her friend Jane, also 7. She's also a 7-year-old girl. And is in the 93rd percentile of the height distribution. Okay, what percentile is Alicia's height, and how does her height compare to Jane's height? All right, so if we look at the answer choices, we don't need to know exactly how much taller she is. We need to know, is she shorter or is she taller? All right, and we do need to find the percentile. So let's see, if she's 0.96 standard deviations above the mean, I don't need these two numbers because they're already giving me a z-score. I can just use the standard normal distribution. So if they're giving me standard deviations above the mean, I can pretend that we're at 0 is our mean, and 0.96 standard deviations would be up here. So we're using the standard normal curve for her. This was Alicia. All right, and we want to find what's this area over here. All right, so we can throw that in our calculator. That's going to be inverse. Actually, it's not going to be inverse norm. That's just going to be regular old normal CDF, right? Because we've already got this value, and we want to know this. So normal CDF, our lower bound is going to be something really small, negative 100, negative 1,000, whatever. Our upper bound is going to be this 0.96. Our mean is going to be 0. Our standard deviation is going to be 1. Now, I bet some of you would probably try and change this standard deviation to an actual value of her height, and you can do that. That's fine. We're probably going to do that in a minute. But for now, we can do it just using this. All right, so now we can throw that in our calculator. So second distribution, normal CDF. We've got a far down lower bound. That'll work. 0.96 for an upper bound. Mean of 0, standard deviation of 1. Press enter until we get us a number, and 0.83. All right, so this area here is 0.83. So that means she is in the 83rd percentile. All right, and Jane was in the 93rd percentile. So if Alicia is bigger than 83% and Jane's bigger than 93%, that means Jane is taller. So that means Alicia would be shorter. So this is shorter. than Jane. So we're looking for shorter, so that's a shorter, that's taller, that's a shorter, that's taller. And we're also looking for 83rd percentile, so 83rds there, 83rds there, so we got both of them here. So Alicia's height is the 83rd, just reading it to make sure, and she is shorter than Jane. Yep, that looks good. And there it is. All right, last one here. So this is just giving you to think about how normal curves work, and this was an AP question a couple years ago. The quality control manager at a company believes that the weights of candies is approximately normal with a mean of 620. Which of the following intervals of weights will contain the largest proportion of the candies in the distribution of weights? Wait a minute. They didn't give us a standard deviation. We don't need it. All right, so if we just look at the graph, 620 is in the middle, and all of these, so 640 to 680, that's a length of 40. 600 to 640, that's a length of 40. This one's got 40, this one's got 40, this one's got 40. So they're all the same length. All right, 640 to 680 would be somewhere, I don't know how far up here, but maybe 640 is here, and 680 is here. So then this would be this little section. All right, and maybe 600 is here. So that would be this section here in the middle. And maybe 580 is here. So 580 to 620, that'd be this lower half. 560 would be somewhere farther down. And 500 and 540 would be way, way, way down here. The way I have it drawn anyway. So that's going to be very little. All right, but what we notice is the closer we are to the mean, the bigger we are, the higher the graph is. So the section that contains the mean is going to be the one that's the highest, and that goes from 600 to 640. That's going to have the most data because that's got the highest part in it. So 600 to 640 is our answer. We didn't need a standard deviation. If we wanted to, we could have made up one and just said standard deviation is 20 or the standard deviation is 40 and solved it from that. It would have given you the same answer. All right, so that's how we do problems with inverse norm and some other normal distribution problems. All right, so you can do all the normal stuff now. So that's it for normal. We are going to go over some other stuff in the next video that's also going to be on this section. So tune in for the next one. Bye.